Welcome to the next unit of our math class, dealing with scale drawings and models. These are your guided notes video. Please take extra special care of these notes. Go ahead and fill in the blanks for your definitions for a scale drawing. A scale drawing is a representation of those objects that are way too small or way too large to be drawn or built in actual size. So therefore we have drawings or models to represent those objects. A scale is something that they use to measure it. Now a scale is always going to be two measurements, so be looking out for those two measurements, because if you don't have two of them, it's not a scale. The example on your notes, first example, is the ratio of the length to the width of a rectangle is 5:3. If the rectangle is 24 centimeters wide, how long is it? So your scale in this particular problem is represented as a ratio. Okay, so what we're going to do in your notes, you say the process. Okay, the first thing that we're going to do is create a proportion where our scale is actually going to take up both tops. Okay, so I'm going to put the 5 here and I'm going to put the 3 here. Now, the order in which it represents in the sentence, so if you notice that the length came first, so therefore the 5 is the length, and then therefore your 3 is the width. So when it comes to that third number, okay, you're actually going to line that up depending on which dimension that it coincides with. So 24 centimeters wide, you're actually going to put that underneath the 3 because it's corresponding with the other width. So then the only thing left to do is put a variable in the empty spot, which is the denominator of the first fraction. And we are going to use the cross products method to cross multiply and divide. So we have 3 times x, which is 3x. And then 5 times 24, which is 120. So if you divide both sides by 3, you end up getting the x value as 40. So remember to answer, go back and answer the question. If the rectangle is 24 centimeters wide, how long is it? So the rectangle is 40 centimeters long. And that is your answer. The most famous scale, I would think, would be that on a map. Okay, so if you look here, this is a scale, and down here in Arkansas, there's your scale. So what we're going to do is we're going to use that scale and the number that they mentioned in the word problem to set up a proportion. Okay, so in Maryland, we have to figure out the actual distance from Hagerstown to Annapolis. So the first thing I'm going to do is create that proportion. Now my scale, which is 1 centimeter equals 24 miles, that's going to go here. So then the number that's mentioned within the problem is going to be the 4 centimeters. Well, that 4 centimeters is going to be in the fraction that's just dedicated to basically your centimeters. Okay, so therefore we need to find x miles, the actual distance. So we're going to do cross multiplication here. So we've got x times 1, which is x, equals whatever 24 times 4 is. Okay, so 4 centimeters actually represents 96 miles on the map in Maryland. Okay, so if you look at Arkansas, they have a different scale. That scale is 1 centimeter equals 20 miles. And again, the number that they mention is 4 centimeters. So that's going to go in the fraction of the centimeters. And then we have to figure out x miles by cross multiplication. So 1 times x is x. 20 times 4, that's 80. So x equals 80 miles. So therefore 4 centimeters on the map is equal to 80 actual miles. Okay, our last example in our notes is another popular scale drawing or representation is that of blueprints. Blueprints are like the #1 source for, you know, carpenters and builders and all that stuff in order to build what they need to build with, like in a house. So here's a blueprint, and what we're going to do is we're just going to focus on bedroom 1. Okay, so if you note the dimensions there, we have 1 inch by 4 inches. Well, on your guys' notes, down at the bottom, it says the scale is 1/2 inch to 3 feet. So here's the trick. When we're dealing with rectangles, we've got 2 dimensions. We've got the length and we've got the width. So we are going to set up 2 different proportions. Okay, 1 for the length and 1 for the width. And we that's normal procedures for figures with 2 dimensions, like length and width. Okay, so for the length, we're going to set up our proportion using the scale that's down there below the picture. Scale is 1/2 inch equals 3 feet. And we're actually going to use that same scale for when we eventually find the width. Okay? So now we're going to go over to the blueprint. 1 inch, that's going to be the width. 4 inches, that's going to be the length. So let's go ahead and put the 4 inches up top under the length and within the inches fraction. Then we have to find out the actual footage of the bedroom. The 1 inch goes underneath the half because we're lining up the inches, okay, in one fraction. And then we have to figure out the actual footage for the width of the bedroom. Okay, now all we have to do is cross multiply and divide. So we have 1/2 x equals 3 times 4, which is 12. You can take your calculator and take 12 and divide it by half. And you get 24 feet. Okay, so that's the actual length of the bedroom, is 24 feet. Now let's find the actual width. So we've got 3 times 1 is 3, and that's equal to 1/2 x. So again, in your calculators, this is a fraction within a fraction. We did some work in our calculators a while ago dealing with fractions within a fraction. So just take 3 and divide it by 1/2. Okay, if you know the decimal version of 1/2, then you can use that too. So 3 divided by 0.5 is actually going to be 6. Okay, so the length, this is the actual length is 24 feet, and the actual width is 6 feet.